Here is math for fun. Find the area bounded by y is equal to e power of inverse x and y is equal to e power of inverse cosx. And look at the graph of y is equal to e power of inverse x is like this and this, and it begins from -1 and then it ends in 1. And the graph of y is equal to e power of inverse cosx, and this is not the inverse. You see, it's higher than this. So e power of inverse cosx is not the inverse function of this. So you see, we're gonna find the area of this. So be careful. We're gonna find the area bounded by these two functions and not this 0. Right? This point is 0. It's not. We are not going to find the area from here to here and not. No, we're gonna find the area of this. So the first thing we're gonna find was our intersection point, so we can set our. We already know our lower limit is 0 and our upper limit is just our. It's called intersection point. You can also call the point between these two functions, right? The meeting point, you can see this. So we're gonna solve our equation. The y value need to be the same, so e power of inverse sine x is equal to e power of inverse cos x. So e and e they cancel each other out, so you can get inverse sine x is equal to inverse cos x. Okay, how can we solve this equation though? And of course, this is a really hard equation. Is inverse trigonometric functions equations. So how will we do this? You see, the range is from this is -1, also -1. Y is equal to e power of inverse cos x. It's from -1 to 1, right? So what value should we put to make these two angles are the same? The answers. We'll see from -1 to 1. The only value we can put is just square root of 2 over 2, right? Because inverse sine of square root of 2 over 2, you get pi over 4. Because sine 45 degrees or sine pi over 4. But this is in our calculus, so we're gonna use our radian. So sine pi over 4 is equal to cosine pi over 4, you know. Their answers are both square root of 2 over 2, right? And you can also write this answer as 1 over square root of 2, and this is the rationalized version. And so our upper limit is just square root of 2 over 2. This is our intersection point between this and that. So we can also find what's this point. You just need to put it inside this, and its coordinate is just, if you put this is the x-axis, and if you put it inside, you get e power of pi over 4, and this is e power of pi over 4, but it doesn't matter. It's just this and this, but the area we're gonna find is just this. So the area is just equal to this. Let's just don't put down the area first. Let me just calculate. The lower limit is 0, and then the upper limit is this square root of 2 over 2. And then we're gonna do our stuff right here. You see, y is equal to e power of inverse cosine is curve is higher than y is equal to e power of inverse sine. So we're gonna first e power of inverse cosine and then subtract. We're gonna subtract because we're gonna find this area first, and then we're gonna subtract the area of this. Right. So you get the area of the bound of this shaped area. You can also say, but this is a black one. So black area. So e power of inverse cosine minus the inside minus e power of inverse sine x dx. And here I'm gonna combine is I'm gonna change this to inverse sine x in terms of inverse sine x, or you can change this in terms of cosx, inverse cosx. But I'd like to change this in terms of inverse sine x, up to you. And here is the identity. Inverse sine x plus inverse cosine x is equal to pi over 2. Because cosine x is this called cofunction of sine x. When the hypotenuse is 1 and this is a right triangle, and let me call, how can we let this to equal to inverse sine x? Yes, it should be x here, because sine this is our theta, sine theta is equal to opposites over hypotenuse, so x over 1, so you can get that. So another one you just get, this is equal to adjacent over our hypotenuse, so this is inverse cosine, and they add up to 90 degrees, but this in our calculus, so this is pi over 2. So I'm gonna change this in terms of sine x, so this is equal to inverse cosine x is equal to pi over 2 minus inverse sine x. So we can get this from 0 to square root of 2 over 2, and then e power of this pi over 2 minus inverse sine x minus e power of inverse sine x dx. And here I'm gonna use our substitution to help us, and we let u is equal to inverse sine x, and then our original one is just equal to sine u is equal to x, right? Original sine, and then we're gonna differentiate both sides. You get cosine u du is equal to dx. Let me just replace this. And here I'm gonna figure out, we are gonna figure out what's the lower limit. Put 0 inside, you get inverse side of 0, you get 0, and then inverse side of square root of 2 over 2. We did that. It's just pi over 4. Just kidding. Oh no, it's pi over 4. Pi over 4 is upper limit in the u world. And then we're gonna get e power of pi over 2, and then minus this, right? U minus e power of u, and then multiply by, and dx is our cosine u du, so we replace this with cosine u du. So how can we do this integral? And here we're gonna use our integration by part. We're gonna put a d and I here, and then we're gonna differentiate e power of pi over 2 minus u minus e power of u, and then we're gonna integrate cosine u. To keep integrating cosine u, get sine u, and then negative cosine u, and then keep differentiate, you get the original e power of pi over 2 minus u, but don't forget about the triangle. You're gonna multiply by the derivative of pi over 2 minus u, so you can get negative here, and then minus e to the u. The derivative of this is just e to the u. Keep going. E to the power of pi over 2 minus u, and the derivative of this. So minus minus become positive. So, and then you get original as well. So this time that we're gonna use this to multiply by this, so you can get e to the power of pi over 2 minus u minus e power of u times sine u, and then we're gonna put some upper limit and lower limit inside. And then here, be careful, minus minus, right, become positive, and then minus, we're gonna factor out the minus, and then so inside it should be e power of pi over 2 minus u plus e power of u times our cosine u. We're gonna put 0 and pi over 4 as well, and then the last one, we're gonna minus the integral. So minus, we can put it outside the integral because negative 1 is a constant, and then e parentheses e to the power of pi over 2 minus u minus e power of u times cosine u du. So this is our original. This is a repeat. It's repeat. So you can put it to here. Add the same integral on both sides, like this and this. So 2 times power limit, put our upper limit and lower limit. And don't forget 2 times the integral of from 0 to pi over 4. And then e to the power of pi over 2 minus u minus e power of u cosine u du is equal to. And here, let me do some algebra. If you pi over 4, put pi over 4 into it, pi over 2 is equal to 90 degrees, and the minus 45 degrees is 45 degrees. So this is pi over 4, right? Pi over 4. And then here, e power of pi over 4 and the minus e power of pi over 4. You just get a 0 here. 0 times sine pi over 4, you get 0. And then we're going to subtract another one. If you plus 0 inside, the whole thing you just get 0 thanks to sine 0. So you get 0. And then we're going to subtract, put a parentheses, put pi over 4 into it. Pi over 4, and then this is just e power of pi over 4. But this time, we're going to add another, not subtract, add another. So this is 2e times power of pi over 4. And then multiply by cosine u here. Multiply by cosine pi over 4. Cosine pi over 4 is just root 2 over 2. We're going to subtract another one. And this time it's not 0 here. If you put cosine, and then cosine 0 is not equal to 0, it's equal to 1. Be careful. And if you put 0 inside it, you get e power minus e power of pi over 2 plus e to the 0, you get 1. And then times 1. It doesn't matter. So you get the original way. Original 2 times original is equal to that. So let me do some algebra, and then 2 and 2 they cancel each other out, and then here we can get e power of pi over 4 times square root of 2. Be sure we have a negative sign outside, and then minus just multiply by negative 1 inside, you get minus e power of pi over 2 minus 1. Wow, this is such a weird answer. And then we just need to put negative sign inside. So you will get the answers. Put negative sign inside, you get negative e power of pi over 4 times square root of 2 plus e power of pi over 2 plus 1, right? And then, but this is not our final answers. The original integral is 2 times this, right? So we're gonna divide by it. So this integral e power of pi over 2 minus u minus e power of u times cosine u du is equal to this divided by 2. So I'm gonna write the negative to here. E power of pi over 2 minus e power of pi over 4 times root 2 plus 1 over square root of 2. So this is not our final answers. We're gonna respond to this question. So bounded area is equal to e power of pi over 2 minus e power of pi over 2 minus e power of pi over 4 times square root of 2 plus 1 over 2. And this is really, really cool, this answers. If you use our calculator, e power of pi over 2 minus e power of pi over 4 times root 2 plus 1 over 2. And this is really closer to be 1.354. And this is really, really cool, right? This area is just 1 point this. And that's it. Whew. Very, very fun.